speak here. I hope you can see my screen and hear my voice, and everything is fine. That's great. Yeah, as said, my presentation is about AI/ML in 5G Advanced and beyond towards AI native mobile networks. It's more a standardization perspective, a 3GPP focused perspective. And we will look on several of the trends and activities towards 6G, what happens with AI/ML with the mobile network. But maybe as a starting point, I think we can say that AI/ML has the potential to reinvent mobile networks. Why is this the case? First of all, we can look on where can we apply machine learning techniques, where can we apply the new methods we learned, for example, from natural language processing, which are very good advances which we have recently seen there. If you think about GTP and other kind of models, these kind of technologies can be applied and will be applied to mobile networks, right? And not only in certain areas like network management, where this has been traditionally been done for some time already, but it will be applied everywhere. So it will be done in the RAN, and this is also happening, of course, already. It will be done in the core. And most recent, also interestingly, it will be deeply embedded in the radio as well. And we'll see a bit later what does it mean also from a standardization perspective and which challenges we can expect from there. But AI/ML is not only a tool, so to say, to improve performance. It implies also a new way of designing solutions and of a new way of working, meaning that solutions are driven by data and not so much anymore in a sense by, let's say, classical type of engineering. So we need different skills also by the people who are working it. We need data scientists which work closely together with domain experts in order to get good solutions. And we also need good operations in order to scale. And scaling is one of the biggest challenges actually of AI/ML for any type of network and also for product development. Good. But let's see, what are, I think, actually the promises of machine learning and AI, and why is everybody doing it? And of course, there are certain, let's say, benefits to be expected and also proven already. One is, of course, the promise of full end-to-end automation, which we have also seen in some of the previous very good presentations already. There's always a promise of cost reductions, of course, if automation will basically eliminate errors and will also remove a bit the human factor. There's a promise of better performance, so not only end-to-end, but also in specific solutions in the radio, as we've seen in the network nodes, better performance of certain functional elements, talk scheduler, talk beamforming, prediction, talk SON-like solutions, load balancing, and so on. All this can be enhanced with machine learning. It can make difficult to solve problems tangible, right? Problems where you would need a lot of computational power to get the optimal solution with some kind of heuristic can be estimated or can be reached in a nearly optimal solution by machine learning techniques. And this is, of course, also more cost efficient, more computational efficient. And finally, we have the promise of continual performance improvements. Meaning that on the one hand, the solutions can basically adapt to changing environment. For example, if you think of a scenario where the radio environment changes over time, and the other is that solutions can be retrained and the performance can be improved. So that's on the promise side, but what is on the challenges side? So on the challenges, first, we have the trustworthiness and explainability, because AI/ML in many senses is often treated or understood like a black box. You put something in and you get something out. But what happens in between? It's often not so clear. And for this, we need techniques to explain why machine learning solutions work And we also need good mechanisms for fallback in case that they, for some reason, do not work in some cases, right? So that's one of the key challenges we need to address. Another one is the data challenge, meaning on the one hand side, how to get the data for the training, for inference. Training, especially if you look on the large models, which need really a lot of training data in the gigabyte, terabyte space, and this needs to be collected somewhere from the networks, right? So the infrastructure needs to be there, the platform needs to be there, the processes needs to be in place. And the same also holds true for the AI/ML framework. And I think the previous presentation we heard about MLOps. So MLOps is basically a key mechanism here. And I've put it also in the last bullet here. Integrating MLOps is needed, otherwise this will not work at scale. Then we have challenges on interoperability, especially in the air interface. So how can solutions on the network and on the device side work together? If they have, in the most extreme case, maybe a joint inference model. And then we have challenges for radio performance requirements, testing conformance, how basically to define requirements if the training phase still needs to be defined and if the training is maybe part of the solution. But okay, all this is interesting and very promising research questions, and also work is ongoing in 3GPP, which will address this. And we see here an overview, and you see here we are approximately here, so end of 2022. And then you see here the different activities. 5G-Advanced already started with release 18, as we know. Currently, we are at the end of the first quarter of release 18, and then release 19 will start likely beginning of 2024, maybe a bit later, depends on how fast 3GPP will be. And then you see here the current activities in regard of machine learning in 3GPP. So one is here this enhancements for network automations, and also the AML sys, which is in the SA2, so system specification group of 3GPP. So this is ongoing for quite some time already, actually since release 16. So in a sense, they are front runner here. Then we have AI/ML in NG-RAN, which basically looks on different use cases like load balancing, energy efficiency, mobility enhancements, and so on, but purely basically from an intra-RAN perspective. So there's currently a work item ongoing, and then we will have a short study and end of release 18, and can maybe expect that something will also happen in release 19 or so. So all this is not yet agreed, right? So release 19 still going to be defined in the coming year. And then we have the study on AI/ML in air interface, and this is, I think, one of the most interesting and promising study which we're currently having in 3GPP, also one of the largest one, with all companies contributing and hundreds of TDocs in each meeting. And here, basically, we look on the integration of machine learning techniques in the radio for a specific set of use cases. We'll have a look later on that. And all this basically will continue and will be the foundation for the AI native 6G system and air interface, which will then start in mid of 2025 as the first study, and then in the specification phase, right? I think the key takeaway here is that 3GP and companies are, of course, working on AI/ML and integrating AI/ML into the system, including the radio. And release 18 5G-Advanced is the foundation of AI/ML in 6G. Important to understand how to shape up 6G. Good. Then if you look on 5G-Advanced in the system, where is AI/ML already integrated from a specification point of view? And we see here a system view. On the left-hand side, we have the devices, and we have the study on AI for air interface as we see. So meaning we have training and inference in device. We could also have training and inference jointly in the device and in the network. We have an AI-enabled RAN with use case-specific enhancements to the interfaces. We have a framework for data collection, training, and inference. And then we have also the AI-enabled system architecture and with the network data analytic functions, which can also serve as a host for inference. And then we have the AI for management, where we have the M-plane, which is has the role of coordination of the AI-ML capabilities in the 5G core and supporting also AI-ML in the RAN. And on top, we would have the end-to-end support for AI application enablers for AI solutions, basically. So a lot of work already ongoing in 5G Advanced. If we look on the 6G side, now focusing a bit again on the radio, and 6G will be the generation which will feature an AI native air interface. And what does it mean? If you look here, the first step is the 5G, where we have the classical architecture of the transmitter and receiver. And there's basically not yet much AI/ML integrated here. Of course, we know there is already something there, but it's basically not yet, let's say, transparent and also not yet visible in the standards, right? And in the 5G Advanced phase 1, where we are currently, the machine learning replaces and enhances individual service processing blocks. This is what we see now. So we see basic enhancements for CSI, channel state information, feedback, or for beam management, prediction, or also for positioning. And for the 5G Advanced phase 2, we can then expect that maybe multiple processing blocks could be enhanced or even replaced by means of machine learning techniques like the machine learning DeepRX. And then finally, the 6G is then the generation where the AI is really integrated deeply into the network, and also the training aspect and the inference aspects are deeply integrated as well. So what is the foundation of this? As I said in the beginning, release 18 study on AI/ML in the NR air interface will be the foundation of the AI/ML integration in the radio of the coming generations, right? Let's have a look what's going on there. And the scope is AI/ML enhancements on the air interface, meaning we are looking on how can we improve certain use cases here. And the study focuses on 3 use cases: the CSI feedback, beam management, and positioning. And the study focuses on how to enable and assist AI/ML in the network in the devices at the same time, right? And this includes different aspects like training. So how can interoperability of AI/ML solutions be ensured if we have different data sets? If the training is done in different places, do we need joint training, or can it done in separate way? This is all going to be studied, and the first results are already available. All the requirements and testing will be addressed here. So the goal is to understand the performance, understand the complexity of the standardization, also of the computational effort, and also, of course, then understand the specification impact. For example, machine learning, life cycle management, use case specific signaling, or network and device collaboration. And just as an example of what that means, one categorization we are looking on are so-called one-sided and two-sided model. One-sided model means we have a machine learning-based solution where inference is done in one side of the network. So if you see here on the left-hand side, we have here the inference, for example, in the network, and we have maybe some signaling enhancement between the UI and the network that improves the operation or the solution performance of the network-based inference method. Or alternatively, we could have a one-sided model in the device, basically meaning we have the same in the device, and maybe the base station could give some guidance to the UI, to the device, when to select a certain model for a given scenario. And then we have the so-called two-sided model, which we see here, two-sided model in the network and in the device with joint inference on both sides. So one good example here is the CSI feedback compression with autoencoder-based two-sided model architecture, meaning that we have here on the UE side, we have the, for example, eigenvector of the current channel, and then the encoder part of this autoencoder structure here encodes this in an unsupervised learning method, and then basically it's transmitted over the air, and it's decoded again on the base station side. And in order to make this interoperable on both sides, so we need to understand how would that work also with if we have multiple vendor and if we have maybe not the same data set and so on. So interesting work here, and I can just everybody encourage to have a look what's going on there. It's highly interesting and groundbreaking from my point of view. Some concluding thoughts. So as said, AI ML in 5G Advanced is the foundation for AI native 6G, and it's a journey of the whole industry towards AI native mobile networks, meaning no company, nobody can do this alone. We need to do this together. We need to work in standardization and research together in order to really unveil the full potential of AI in the whole network, right? And our approach is we'd like to achieve standardization excellence by deep and thorough technical evaluation, meaning we should not always fall for the hype. AI ML is not the solution for everybody, for everything, but we need to really understand the gains, we need to understand the complexities, and we need to understand how to implement in the end a good and efficient solution. And this concludes my talk. Thanks a lot, and open for questions now.